I will be doing 3 examples from section 3.4, and I'm going to be doing number 35, 37, 39, take that back. That's going to be 57. So 35, 39, 57, and 59. This is on product and quotient rule. So number 35, we have this. 1 plus 2x plus x e to the x. And then we are going to get the equation of the tangent line also. We'll deal with that second. So first we need the derivative dy dx. Pretty straightforward. The derivative of a constant is 0. So that's just 0. Now for this one, there's an imaginary 1 that you don't see right here. So you bring the 1 in front. So we have the 2. We bring the 1 in front. And to that 1, we decrease it by 1. So you actually have a 0 power there. Plus, and here is where the problem lies. You have to recognize we have a quotient, or excuse me, a product rule. So in the product rule, you leave the first one alone. You take the derivative of the second, and then we take the derivative of the first, and we leave the second alone. And thus we get this. Well, you should know anything to the 0 is just 1. So we end up with 2 plus x e to the x plus e to the x. And then the question continues. They want the equation of the tangent line through the point x1 equals 0. So they want the equation of the tangent line at x equals 0. So to give you a better understanding of that, we're going to graph this function, and that's actually part of the question. 1 plus 2x, x e to the x. I'm going to do it in Desmos. It's going to be y equals 1 plus 2x plus x, and we have e raised to the x power. And if we look at this graph, wow, that's kind of crazy. Now, excuse me, the scales are way off here. If you look, my x, that's like 500 in each direction, or 1,000 to the right. So on the x, let me go negative 10 to 10 and see what that does for me. Now, I had to scoot to the right a little bit more. And now, if you look at the y, that's like 5 million. That's really big. So I'm going to change my y's to reasonable numbers. I'm going to go negative 10 to 10, just see what it looks like. And that's looking a little better. I can back out. And so there's the graph. Now, what do they want? I'm going to screenshot this and show you what they want. So let me screenshot. So they want the equation of the tangent line at x equals 0. So if you put a dot here at 0, they want a line that's tangent at that point. So roughly, I'm going to get that line. And they want the equation of this line here. And the point of tangency, you have to realize, is x1, y1. That's that point. And then we have to find the slope, which we know is the derivative. But since we want the slope at the point of tangency, we want it at that x1. And that x1, they told us, is 0. So we got to go back, find out what our y1 is, and find out what our slope is. So let me jump back to whoops, not that one, notability right here. So we know our x1. How do we find y1? What tells us the y value? Well, the original function tells you your y value. So we're going to plug 0 into that. 1 plus 2 at 0 times 0 plus 0 times e to the 0. Well, simply that's just 1. So our point of tangency is 0, comma 1. So now we need one more thing. We need the slope. And you should know by now the slope of the tangent line is the derivative of the function evaluated at the point of tangency, which is 0. So into this derivative equation, I'm going to plug a 0 in. 2 plus 0 times e to the 0 plus e to the 0. Well, this is easy. 0 times anything is 0. And e to the 0, whoa, what just happened? I don't know. E to the 0 is 1, so we have 2 plus 1, or 3. So now we have our point of tangency, and we have our slope. And you all should know the equation of a line in point-slope form is that. And we plug in our known point. So our 1 goes in for our y, our 0 goes in for our x, and 3 goes in for our slope. And we are done. 1 minus y minus 1 equals 3, x minus 0. Now, that answer is fine. You can rewrite it like that. If you want to, you could add 1 to both sides. It doesn't matter. They're all proper, but just realize they're all the same. So that's number 35. We're going to go on to 39. So 39, this is part of the product and quotient rule, but there's an important thing to know. G of t, let me get this equation, is 3t squared plus 6 over t to the 7. Now, you can notice something right away. This is a quotient rule. Numerator, denominator. We should do low d high minus high d low over low squared. And to do that would not be wrong, but to do that would be a waste of time. So as you become better calculus students, you realize that you can rewrite things to make your life easier. So I can move the t to the 7th to the top, and it becomes t to the negative 7th. Now the derivative is simply doing our power rule. The 2 comes in front, and we decrease the power by 1, so we get that. The negative 7 comes up in front. We decrease the power by 1. Negative 7 minus 1 is negative 8. And now I can rewrite all of this. That's actually going to be a minus 42 because a plus times a positive times a negative is negative 42. And the negative 8 brings that to the bottom. There is our derivative without using the quotient rule. Now, we can use the quotient rule if you want to. And so let me show you using the quotient rule, and you'll realize why it's wise to look to rewrite problems. It just makes life a little bit easier. Okay, the first one's easy. We know it's 6t. Let's use the quotient rule now. Low, d high, the derivative of 6 is 0, minus high, d low, the derivative of the bottom is 7t to the 6th, over low squared. So now we have to simplify. That's 0. So we have negative 42 t to the 6th over t to the 14th. Because an exponent raised to a power, you multiply those exponents. Make sure you know those rules. And now we have to simplify. It's minus 42. So you have 6 t's on top and 14 on the bottom. So 6 of those t's will cancel out with 6 of those t's. And that's going to leave you with 8 of them on the bottom. And I'm a bit concerned because our answer is not matching. Let's figure out where our mistake is. Okay. Oh, there's no mistake. That's the right answer. Because look, here's my previous answer, and here's my new answer. Now, quotient rule gets the right answer, a lot more work. So be smart and realize I can rewrite this and have just a regular power rule and no quotient rule and get the answer quickly. So that's number 39. We're going to quickly move on to number 57. So 57, it's going to be kind of ugly. And I recommend doing side work, because if you don't do side work, you can make a lot of careless errors. So the first thing you have to know, there's an implied parentheses. When you have a big fraction bar, there's implied parentheses on top and bottom. So now it should be clear that we have a quotient rule. So we take low times the derivative of the high. Now I have a problem because that's not a simple derivative. I'm going to leave it like that. So low d high minus, now I just copy the high and take the derivative of low, which is just 1, all over low squared. Now here's what I mean by side work. Taking the derivative of that, you could try to do it all at the same time, but I'm going to do that off to the side here and then plug it back in. So this is a product rule. You're multiplying two things. So to find the derivative, you leave the first alone, and you take the derivative of the second. I am my own grandpa, so it stays that. Plus, you take the derivative of the first and leave the second alone. And so I distribute the e to the x. And if you have an e to the x and you have another one, by golly, you have two of them. Now, if you wanted to, you could factor the e to the x out and be left with x plus 2. I don't know if I want to do that, but I'm going to bring this answer back up top and see, is it going to help me to have it factored? I don't think so. I want to leave it in unfactored form, so I'm going to copy the x e to the x plus 2 e to the x. Minus, and then I have an x plus 1 e to the x all over x minus 2 squared. And it's getting pretty ugly on top. I don't see any quick solutions. So here's what needs to happen. I need to distribute that x to both of those. So if I do that, I get x squared e to the x plus 2x e to the x. Then I have to distribute the negative 2 to both of those, which gives me minus 2x e to the x and minus 4 e to the x. And then we're left with the remaining piece, which we have to distribute, but I have to distribute that negative also. So it becomes minus x e to the x minus e to the x, and that's all over this big thing. And now we look and combine like terms on top. And am I happy? I am, because look, 2x e to the x minus 2x e to the x, those will be gone, which is nice. Anything else? Well, this x squared e to the x isn't going anywhere. And then I can combine these two. I owe 4 e to the x's, I owe another one, therefore I owe 5 of those. So I have minus 5 e to the x, and that minus x e to the x is left over, and x minus 2 squared. Now on top, I do have a common factor. If you'll notice, all three terms have an e to the x. So I'm going to take that out. And what am I left with? Well, I'm left with x squared minus 5 minus x all over x minus 2 squared. And just to make it prettier, I'm going to rearrange these numbers. And hopefully that's right. There's a chance I made a dumb error, but I believe that's the answer. So what we had was a quotient rule, but in the midst of doing the quotient rule, we ended up having to do the product rule. So it's a double 2 rules in one. And that's pretty common, so we need to get used to that. I have one more to go. Let me get rid of this stuff here. And we have one last one, number 59. And this one is kind of ugly also. It's a double rule that's happening. H of x is x e to the x, but this one's not as bad. Over x plus 1. Remember the implied parentheses, so we have a quotient rule. So we have low, that's easy. D high, that's not so easy. So I'm going to write that as the derivative of the high minus high, that's easy. D low is just 1 all over low squared. Why did I write 52? Should be 59. Don't know what's going on here. 59. So I highly recommend side work. It's dangerous doing things in your head. I'm going to copy and I'm going to paste that here. Whoa, I don't want that line. So we have product rule. Two things are being multiplied. So when I take the derivative, I leave the first alone. The derivative e to the x, I am my own grandpa, plus the derivative of the first is 1, and leave the second alone. So that is my derivative. So I'll replace this with that. X e to the x plus e to the x. So my next line will be x e to the x plus e to the x. Whoa. And minus x e to the x. Now it's time to simplify. I need to distribute. This x needs to be distributed to both of those. So I'll get x squared e to the x plus x e to the x. The 1 needs to be distributed, so plus x e to the x plus e to the x. And I have the rest of the equation on top. And now I start combining terms, and I'm happy to see those will be gone. And notice I do have a common factor. All three of these have an e to the x. So let me take that out. So on top, I'm going to be left with x squared plus x plus 1 over x plus 1 squared. I hope that's the answer because that's what I got. That's it for this video. Bye-bye.